Welcome to the Explainer. So today, we're going to tackle a really powerful tool that helps us make sense of the world, especially the parts we can't observe directly. It's kind of like being a detective, and our main tool for cracking the case is something called a Hidden Markov Model.
So, think about this for a second. This is the exact kind of puzzle that leads us straight to a Hidden Markov Model. Now, I know the name sounds a little intimidating, but stick with me here, because the idea behind it is actually super intuitive. Let's dive right in.
Okay, to get our heads around this, we're going to start with a world we can see, using what's called a simple Markov model. And then, we're going to add a twist.
Right, so in a simple model, everything's out in the open. The state is known. If you can see that it's sunny today, you can make a pretty good guess about tomorrow's weather. But what if the windows are blacked out? What happens when the state itself, the actual weather, is hidden from you? And that, right there, that's the jump to a Hidden Markov model. We can't see the cause anymore, we can only see the clues it leaves behind.
So, when the true state of things is hidden, we have to rely completely on what we can see. These are our observations, or as I like to call them, our clues.
Let's imagine the true state of the weather, the thing we're trying to figure out, can only be one of these three things: sunny, cloudy, or rainy. But remember, we're stuck inside that windowless room. This is our hidden reality.
And the only thing we can see, our one and only clue, is what our colleague wears to work each day. Are they in normal clothes? Are they carrying an umbrella? Do they wear a full-on raincoat? These outfits are our only link to that hidden world of the weather.
Okay, so we have the hidden states, and we have the clues. How do we actually, systematically connect the two? This is where it all comes together. The key that unlocks this whole thing is called an emission probability. It sounds fancy, but all it is the chance of seeing a particular clue given a particular hidden state. So, what's the probability of seeing a raincoat if we know it's sunny? That's an emission probability.
Okay, now this table is where it gets really interesting, because this is how we quantify that connection. So if it's rainy, there's a 50% chance our colleague wears a raincoat. Makes sense. But get this, there's a 10% chance they wear a raincoat even when it's sunny. Wait, what? Why on earth would that happen?
And boom, there's your answer. This is exactly why we need probabilities. The real world isn't black and white, it's messy. Maybe this person lives in the mountains and is just being cautious. Our models have to be flexible enough to account for that kind of uncertainty.
All right, let's make this real. Let's get our hands dirty and actually calculate the probability of one very specific sequence of events happening.
So, here's our challenge. We see a sequence of outfits over 3 days. Raincoat, then normal clothes, then an umbrella. And, just for this first example, let's pretend a little birdie told us exactly what the weather was on those days. Rainy, then sunny, then cloudy. Our job is to figure out what were the odds of that exact scenario playing out.
It's actually a pretty simple process. We can break it down into 3 steps. First, we figure out the probability of that weather sequence happening. Second, we find the probability of seeing those outfits on those weather days. And finally, you just multiply the 2 results together.
So part 1 is all about the hidden weather itself. We need to figure out the odds of that specific pattern occurring. What's the chance of it going from rainy one day to sunny the next, and so on.
And part 2 is about the clues. This is where we use those emission probabilities we just talked about. We calculate the chance of seeing those specific outfits given the weather on each day. Let's just pull a couple of those values from our table to see how it works.
All right, so for day 1, we saw a raincoat, and we're saying it was rainy. We look at our table, and yep, that probability is 0.5.
And for day 2, we saw normal clothes and we're saying it was sunny. Back to the table we go, and that probability is 0.6. We do the exact same thing for the 3rd day. Easy enough, right?
So, the final answer? You literally just multiply all of those little probabilities together. The probability of the weather path itself times the probability of all the clues we saw along that path, and that gives you the total likelihood of this one single specific scenario ever happening.
Okay, let's get to the final piece of the puzzle, because this is where the real power of Hidden Markov models kicks in. But wait a minute, calculating the probability for a path we were given is one thing, but that's kind of cheating, isn't it? The whole point is to figure out the hidden sequence when we don't know it. We want the model to tell us what the weather was most likely to have been based only on the clothes we saw. So think about it.
If we have just a 4-day sequence of observations with our 3 possible weather states each day, how many different combinations of sunny, cloudy, and rainy could there possibly be?
81 for just 4 days. There are 81 completely different possible weather sequences. That's a lot. Can you imagine having to calculate the probability for every single one of those 81 paths just to find the one that fits best? I mean, who has time for that? And that is the absolute genius of a hidden Markov model. You don't have to calculate all 81 possibilities. These models use incredibly clever and efficient algorithms to sift through that entire forest of possibilities and point directly to the single most probable hidden story that explains the clues you saw.
And of course, this goes way beyond just predicting the weather from inside a room. We're talking about finance, biology, the speech recognition that's probably listening to me right now. HMMs are everywhere, working behind the scenes decoding the hidden patterns that drive our world. It really makes you wonder, doesn't it? What other hidden patterns are all around us, just waiting for us to find the right clues?